Hello everyone, today we're going to talk about difference of squares, and basically the main idea of different squares is, so let's say you have something like this, so a take away b squared. What like this is, like the law of it to like find out questions like blah blah blah, is basically you create brackets and you put a and b and then another bracket a, but this time minus b. So the idea is that because it's a square, there are two numbers, and we do have those two numbers, and most of the time, basically, it has to be a negative because that's the difference. You can't have positive because then they add and all that type of stuff. Like negative is when you need the difference. When it's a positive, when it's an add, it doesn't work. So an example of this, I can tell you, like let's say we have x squared take away 25, right? We know that like a square number of 25 is 5. So we just put x plus 5, and then x take away 5, and that's the answer. So I'm not really sure how it can help in maths, problems and all that type of stuff. However, yeah, it is what it is. So then now let's say we have something like this, right? Oh, take away 64. So now after that we have to think of a number that times itself to give us this. Well, this might seem hard, however it's more easier than you think. So look, basically this whole term is squared. I don't think I wrote this good because this looks like only this is squared, but this whole thing is squared. And so 2 times 2 times 2 times 2 is 4, and x times, I want to write it in a good way, like I don't want to make it ugly anymore. 2 times 2 equals 4, x times x equals x squared, and that's what we have. So basically it's going to be x to x plus, what's going to be plus a number that is squared basically it's going to be 8. Then same thing here. So yeah, we can use some more space. And after that, let's say we have something like this. Very easy again. 3, because 3 times 3 is 9. So 3y plus 10 because that's what gives 100. And it's kind of exactly, so yeah, that's the final answer. And it's exactly the same if we had like, let's say we have something like this, right? So you might think it's more confusing because you have more of like variety or whatever, but no, it's like basically the same thing. 7 over here, that is hard, yes, but you just can't put in a calculator, you can put something like, you can put this and it's going to give you the number. Oh, yo, what? That's actually interesting. Let me check this on my calculator. Square root of 169. Oh no, it gives me 100. It gives me 13 on my calculator, like, and without a decimal. So I don't know why it does that on this thing, but whatever. So, and over here it's just gonna be x, and over here it's just gonna be y. So 7x plus 13y, and then over here 7x negative 13y. So that's what it's for this. Now let's think what else I can show. Okay, so let's say we have something like this, right? it's going to be x squared, as we already know, plus 9. And then we have x squared negative 9. So look, this time, this is not the final answer. I mean, I don't know if we had examples like this before. Did we? Oh, amazing, we didn't. So look, 9 is a square number. It can be created by two same numbers. So, let me show you. No, let me first of all explain. Okay, no, let me just do it. So, the final answer would be x squared plus 9, and then x plus 3, x minus 3. So this would be the final answer. The reason we didn't do anything with this 9 is because, look, so there's no difference. It can't be like, so look, let's say, So look, you kind of think of it like this. When you, for example, would expand it, 9 times 9 equals negative 9, not 9. So, and we need a positive 9 because, like, how can I explain? Negative times negative equals 9, like a positive 9. So whenever it's basically a negative, you can do factorization. If not negative, then you really can't. That's why each time, even right now, I'm going to give you a question. It's going to have a minus in it. First of all, yeah, so look. So let's say, look, again, a minus. And how we do this is basically just like last time. So 2, well, this one is more confusing. However, in this case, oh no, it should be a 4. So 2x y squared, cubed, because, yeah. Because when you, like, times them, because remember this is times with times in them, it gives us, it doesn't exactly, I mean, basically, yeah. Then x squared negative, oh wait, I did it wrong. Negative 5, plus 5. I have done. Now let's think of another example. Okay, let's say we have something like this. So you have in brackets already. So basically I have this, right? It's basically what we have as a result of the last ones, but we can simplify it. So imagine this is just an answer to one of the questions. You just simplify it, kind of, but in the same way as you answer the question. So we see the square, so we can have two of them. We see the minus, so it's a difference. So what we do is we just put a bracket and a bracket, x, 3x, plus 5y. The reason we don't change the numbers is because this whole thing is squared, so it's kind of like not, basically we can open them and make it a 9, make this 25, but it's going to have the same result as this, so it doesn't really matter because, like, it's just logic. And then for bracket 4x plus 7y, and then Oh, and then oh, and then it's just going to be bracket 3 plus 5y minus 4x plus 7y. So, and after that, okay, basically after that we kind of add all of this. So look, first of all, let's count how much x's we have. We have 3x, 4x, 3x, and then over here negative 4x. So this 7, 10, no, this, yeah, 7 and 10. And then take away 4 equals 6x. Wait, what? Oh no. Sorry guys, I got confused. Basically, you treat these two separately. So basically, you add only these two, so 7x, and in the bracket, by the way, and then these two plus 13, no, 12y, and then in the other bracket you do these, so 3 minus 4, 1x minus 1x, by the way, and then these, and since over here there's negative, it doesn't matter about the positive here. It's going to be 5 minus 7, and that's going to be minus 2y, and after that, we're not able to have this as a negative, like this should not be a negative, so instead of making it negative, we can just do this. We can put this, so this is going to be our final answer. And the reason for that is, yes, there's a negative here, but it's not in the brackets, and yeah, that's why it matters in this case. So now, let's do another example just quickly. So bracket, oh, x plus 3, bracket closed, 3 minus 16. So here, it is in like one big bracket, however, it's the same thing. So first we do this thing, x plus 3, and then we do plus 4, and then we do another one, x plus 3 minus 4, and then there's going to be and then over here we will have x plus 7, and over here we will have x minus 1, and that will be our final answers. And a very confusing one is going to be this right now. So look, so let's say we have something like this. Take away 4, 9, B to C8 over 12, 22. So this may seem scary, but it's basically the same thing, but just with fractions. So look, again, main idea is you divide by 2. So, or like square root. So here, first, let's do this one, and then this one after. So 2a3, 3, because 3 times 3, basically you should know it by now. Also in brackets, plus, now we do this one, 7. This is going to be B, this is going to be C4, and then this is going to be 11, because 11 times 11 is 121, 11. And then in another bracket, 2a3, 3, and then 7bc4, 11. And can we simplify it any further? Or, well, no, because over here we don't have any similar like a's, like we don't have anything to cancel out. So this is the final answer. Yeah, this is all of it. Thank you, goodbye.